Welcome, guys. We are going to be going over some of the types of questions that you're always going to be asked on free response problem number 4. On free response number 4, you're going to be doing 3 reactions. In order to also review equilibrium, I made the questions about these 3 reactions related to equilibrium. At first, they're always going to give you the same example, and it involves putting a strip of magnesium in a solution of silver 1 nitrate. They'll have it worked out for you, but I'm going to do this just so you remember. A strip of magnesium could be Mg with a 0 charge. It's in a solution of silver 1 nitrate, so we're going to show those ions separated. Oh, that's a minus, sorry. And in order for Mg to participate, it has to gain a charge. We know that Mg is going to go up to +2. That means Ag is going to go down to 0. Mg is going to hook up with NO3. Those are going to stay apart. And Ag is going to be reduced. Cancel the spectator ions. In this case, it's NO3. Balanced charge. And we have our overall reaction. Mg plus 2Ag goes to Mg plus 2 plus 2Ag 0. Who's oxidized? That's a substance that goes up in charge. Mg goes from 0 to Mg2 plus, so it's oxidized. It would also make it the reducing agent. Okay, that was just meant to be a quick review. Let's go to the major questions now. There will always be 3 on free response number 4. This first one. Butane gas is burned in air. I do not see any ions, so I'm going to go to my cheat sheet. Butane is C4H10. If anything with carbons is burned in air, we are going to do a combustion reaction, CO2 gas plus H2O gas. Balancing it, I'm going to put a 4 here. I'm going to put I'm going to put a 5 here. I'm going to put a 4 here. I have 8 O's here, and I have 5. That gives me 13. So I'm going to put 13 over 2 there, and I'm just going to leave it as 13 over 2. Which direction would this reaction shift if the temperature was decreased at equilibrium? Okay, first off, everybody counts because they're all gases. Secondly, they're talking about temperature. So, this reaction is exothermic. It means delta H is less than 0. Okay, if delta H is less than 0, increasing temperature makes it shift left, and decreasing temperature makes it shift right at equilibrium. This is from the sheet that the sub should have passed out to you today. What direction would this reaction shift if the temperature were decreased? The answer is right. Yay! Yay! Moving on to B. A piece of solid sodium, so Na0, and it's solid, is dropped in liquid water plus H2O liquid. Okay, we don't see any ions, so we're going to have to go to our cheat sheet. And according to the cheat sheet, this is what you get. It's an alkali metal placed in water. We're going to get a basic solution from this after it's balanced. Hydrogen is a gas, and these ions are separated in solution. Right here, they're separated, so they have to be aqueous. So, initially, how would diluting this reaction with more water shift the equilibrium? So, the gas counts, aqueous counts, the liquid doesn't count, and the solid doesn't count. How would diluting this reaction with more water affect the equilibrium? Nothing. Will not affect. H2O is a liquid. According to this, it tells you it's a liquid. Liquids do not affect the equilibrium. Going to C. Solid potassium chlorate decomposes when heated. Okay. Potassium chlorate would be KClO3. And that came from K, which is +1, and chlorate, which is -1, and it's solid, so they are going to stay together. Strongly heated. It's tempting to want to put a +O2, but heated does not mean burned. Anytime you see the word burned, that's going to be the +O2. This is heated. It's not burned. We do not see any ions, so we have to go to our cheat sheet, and according to that, produces KCl and O2 gas. All right, we're going to say this is aqueous, and we have to balance this reaction. So according to this reaction, I have 3 O's here, I have 2 here. So I have to put 3 here, 2 here, put a 2 here. Here we go. How would increase in the volume of the reaction chamber shift the above reaction at equilibrium? So again, we're dealing with equilibrium. Solids are not going to count. Aqueous and gases will count. I know it doesn't explicitly tell you that that's aqueous. I'm assuming that now. It will explicitly tell you on the test. So we're dealing with volume. Go to my sheet. If you increase volume, you shift to more moles. If you decrease volume, you shift to less moles. There are 2 moles on the left, and we have 5 moles on the right. Increasing volume would shift to more moles. So this would shift to the right to shift to more moles. And that would actually be to occupy the added space. Thanks a lot. See you guys tomorrow. Bye-bye.